Yes, good morning, students.
Good morning, sir.
Yeah, my voice is audible.
Yes, sir.
Yes, sir.
Yeah. So wait, I will share my screen.
Sir.
So it is also visible.
Yes, sir.
Okay, thank you, ma'am. Yeah, last class we discussed about uh, governor, types of governors, right? The how the VAT governor, how it works, the working principle of governor, the types of governor. No, the we discussed the three types of governor. One is VAT governor, second one is porter, and third one is hotnell governor, right? And also last class we discussed about some basic concepts. These are 7 basic concepts. First one, controlling force, a force which is acting radially inward, means towards the center of the governor shaft axis. That force is called as a controlling force. Its magnitude is equal to a centrifugal force mr omega square but act in opposite direction to make the governor shaft or governor arms of balls in stable position, and it makes stability also. Now we know that how the governors are stable based on by drawing a centrifugal force versus the radius of rotation and controlling force versus the radius of rotation. We have considered three equilibrium positions. First, consider equilibrium position is the radius of rotation of the governor ball is r. Means what is the radius of rotation means is a distance between horizontal distance between the CG of the mass to the shaft axis, or perpendicular distance between the shaft axis and the CG of the mass. There is a horizontal distance that is called as a radius of rotation. See the radius of rotation of the governor balls governor ball. Now you consider three equilibrium position. One is R, second one is R1. R1 will get when increasing speed, the radius of rotation is increases from R to R1. R1 is greater than R. Similarly, if you go for decrease the speed from the equilibrium position, then it decreases the speed decreases, radius of rotation of the governor ball also decreases, that reaches to r2. Now r2 is less than r. These three you consider as the equilibrium position. Based on that equilibrium position, first you draw the centrifugal force line, that is a straight line. Then you go for draw the controlling force curve, that is AB. Then you go for take R is equal to R1, draw a vertical line that intersect both a centrifugal force and controlling force. Then you can see this that the AB line, this point, the controlling force is greater than a centrifugal force at R is equal to R1. Then you can say that what is the condition here? Stable means it has to do its function here when the when the ratio, that is when the slope of the curve d by dr of f of r is greater than d by dr of f, then it is the controlling force curve, the slope of the controlling force curve is greater than the slope of the centrifugal force, then you can say the governor is stable. Governor is stable means if you increase the speed, the radius of rotation of the governor ball also increases. If decrease the speed, the radius of rotation of the governor ball also decreases, then it is called as a stable. Unstable means this will be the condition for unstable. If it is a d by dr of controlling force less than the slope of the centrifugal force, right? And third one is isochronous means when centrifugal force and controlling force both the curves are become a straight line and it equal, then it is become a isochronism. This should not exist here. And second one, we discuss sensitiveness of governors, means how quickly the governor will sense whenever the change in speed of a governor shaft axis takes place, or engine speed, the change in engine speed takes place, then the governor has quickly responds to it. That is called as a sensitiveness. Again, we have a two speed. One is the minimum speed at we consider the full load condition. Second one is consider a maximum speed at no load condition. There is no load means the engine speed rotate at high speed. Once engine speed rotate at high speed means the governor shaft also rotate at high speed only. Now what is the sensitiveness? How do you define it? It's a ratio of mean speed to the maximum speed. How do you get the mean speed? That is the sum of the minimum and maximum speed divided by 2. Range of speed, the difference between these two, maximum and minimum speed, that gives a sensitiveness. After that, hunting, our aim in the device aim is to maintain the engine speed within the limit, or maintain the constant speed, maintain the mean speed. But governor is not able to maintain the mean speed, that will maintain within the limit only, that will maintain. They will go for increase from the mean speed, it will go for plus or minus 5% speed, it will increases or decreases. That is a process of maintaining the mean speed, that is called as a hunting here. Then isochronism, when the isochronism is exist, we know that sensitiveness of a governor is a ratio of mean speed to the range of speed. If range of speed is 0, anything divided by 0 will get infinity, means it become a infinitively sensitive. Means it will not sensitive, it means for all the speed, for all the radius of rotation, the speed is remains same. Okay. This means for all position of the sleeve or the balls, the governor has the same speed. Means the governor will not perform its function. Next, stability. Already we discussed what in stability means. If the speed, the governor shaft axis increases radius, increases speed means the radius of rotation of the governor ball also increases. If the governor shaft is decrease its speed means radius of rotation of the governor ball is decreases. That you can say the governor is stable. Unstable means if the speed is increases, what happen? The governor shaft axis, the radius of rotation of the governor ball is decreases. If you decrease the speed, the radius of rotation of the governor ball is increases. That is become unstable. I mean, once the governor is unstable, it will not to do its function properly. Okay, then you go for repair it or replace the another governor. Next one is effort of governor. Effort is nothing but a force is required to move the sleeve upward and downward. How much force is required to move the sleeve upward or downward? That force is called as a effort. See that the effort of governor is the mean force acting on the sleeve to rise or lower it for a given change of speed. Now for each side, the effort is represented as E by 2. Total sleeve mass is mg, but on if you consider from the governor shaft axis, the two governor balls are there. From each side, how much effort is required here to move the sleeve, or to rise the sleeve or to lower the sleeve from each governor uh, ball. What is the effort is required from the each governor ball means that is E by 2 because two governor balls we used here. Next, power of the governor or work done by the governor is nothing but, as you know that the sleeve moves up and rise, there is a displacement in the change in position of the sleeve takes place. Then how the change of position takes place? Unless until an effort or a force acting on the sleeve. The force into displacement you will get a effort of the governor. Sorry, effort not power of the governor or work done by the governor. Effort into displacement of the sleeve. These are the 7 basic concepts you should remember. Yes, any doubt regarding this previous session? Yes, unmute yourself. If you have a questionnaires, please ask me. I'll try to clarify your doubt. Yes? Yes, no doubt. Yes, unmute yourself and give me response. Yes, my voice is audible.
Yes, sir.
Is there any doubt regarding the previous?
No, sir.
No doubt?
No, sir.
Okay. Now our next topic today, what we are going to study here, the Porter Governor. As you know that, how do you introduce Porter Governor? A Porter Governor is a what type of control it is? A centrifugal type. Under that, what type is gravity controlled? A gravity controlled, centrifugal type, energy controlled type governor. This is the introduction of Porter Governor. Porter is a scientist name. Okay, a governor. Porter Governor is a gravity controlled, centrifugal type and energy controlled type governor. Right, that is the introduction. Next you go for construction. How did the Porter Governor is constructed here? The Porter Governor consists of a 4 binary links. See the 4 binary links. So it consists of a 4 binary links. This is called as link number 1 and this is link number 2. Link 1 and 2 are called as upper arms, and link 3, this is a link 3 and this is link 4. Now it consists of 4 binary links, 2 upper arms. Those 2 upper arms are connected to where? Connected to a governor shaft axis that pivot at point O. One end of the upper arm is connected to a governor shaft axis that pivoted at point O. Other ends of the upper arms connected to where? Connected to a governor ball, or we call as a mass, governor mass, ball mass. Then another two arms are there. Those are called as the lower arms. The lower arms, one end of the lower arm is connected to the governor ball. Another lower hand is connected to where this component is called as a sleeve. The sleeve is nothing but is also a heavy mass a component. Okay, it's this mass is greater than the sleeve mass is greater than the governor ball mass. Okay, actually it is connected to the sleeve here. Here for our purpose, we'll just show the one more link here. Now this link BC, that link will not consider for theoretical purpose. Okay. Now again you consider, now it consists of four arms or four links, binary links, two upper arms and two lower arms. Two upper arms are connected to a governor shaft axis that pivoted at point O, and the other two ends of the upper arms connected to governor balls. And lower arms 3 and 4 it is connected to a governor ball, and another end of the lower arms is connected to a sleeve, right? Now consider the mass of the governor ball is m, and at equilibrium position the radius of rotation of the governor ball is r, right? Now once it start to rotate, once it's the governor shaft is on the one more, the mass of the sleeve is represented as capital M. Capital M stands for mass of the sleeve, small m stands for mass of the governor ball, and radius of rotation of the governor ball is r, right? Due to mass of the governor ball, the weight of the governor ball is m into g, that acts vertically downward. At the same time, the sleeve mass is m, capital M. The weight of the sleeve is acts vertically downward. That weight how much here? M into capital M into G. Now, once the governor shaft rotates at angular velocity omega, that is equal to 2 pi n by 60. 2 pi n by 60, right? When governor shaft rotates at angular velocity omega, what happens? Due to that, the arms also rotate about the governor shaft axis. The governor balls also rotate, sleeve also rotates. Due to that, a centrifugal force which is generated from the a governor ball, that magnitude is mr omega square. That acts where? That acts radially outward. That acts radially outward. Due to centrifugal force acting on the governor ball that acts radially outward, that force is called as centrifugal force, a force which acting radially outward. Due to that, what happens? A tension T1 is occurred in the upper arms. See that arrow mark what I am showing here? This is T1. A tension T1 is occurred in the upward direction. Now, due to this tension T1 is occurred in the upper arms here, what happens? The upper arms moves radially outward, means the governor balls moves radially outward, right? At the same time, at the lower arm also, you can see the tension T2 is occurred here. The tension T2 is occurred in this direction. Now before that, at equilibrium position, now see that the angle subtended by the upper arm with respect to what? Governor shaft axis, that angle I will call as a alpha. That angle is called as a alpha. At the same time, if we take a lower arm with respect to a governor shaft axis, the lower arm, that angle I will call as a beta. Beta. Once the governor shaft rotates at angular velocity omega, the upper arm moves radially outward. What's the tension occurred in the upper arm is T1. At the same time, what is the tension occurred in at the lower arm? It is a T2. Okay. At the same time, once the tension occurred here, when the governor bus moves radially outward, the initial radius of rotation is r. Now the r is changes to it. R is changes to R1. Now R1 is greater than R. The radius of rotation is increases. Once the radius of rotation increases, the tension T1 occurred in the upper arm. This side T2 is occurred in this direction. At the same time, sleeve moves what? Upward direction. Sleeve moves upward direction. Now you can see the figure number B. We'll consider only the up portion on the left side portion of the porter governor. We consider only the left side portion of the porter governor. Will consider. Then we'll go for derive that how much The what is the height of, the height of the governor is nothing but it is the vertical distance between where the mass of the governor ball is here. Here this is a vertical distance between the governor ball CG to the pivoted point of the upper arms. This is called as the height of the governor. We call as what, how the height of, as know that the angular velocity is increases. The angular velocity of the governor shaft increases. Now it moves, the upper arms moves radially outward, right? So the h is initially the equilibrium position. H is this height of the governor. Height of the governor means is the vertical distance between the pivot point of the upper arm and the governor shaft axis and the radius of rotation of the governor ball. This is a vertical distance, that is called height of the governor. As the speed increases, as the speed increases, the governor ball moves radially outward. What happens? This height is decreases here. Now suppose as the speed increases, now A become A dash here. Now what is this will be, A become A1. Now this will be the position we'll get here somewhere. Okay, as the speed increases. What will be this height? It is, this is also height of the governor. Height of the governor, that is we'll call as H1. When the radius of rotation of the governor ball is, this distance is called as R1, right? Now this is our aim is to determine what will be the height of the governor when the governor rotates at the equilibrium speed. Okay, that small derivation is there. Yes, any regarding this theory part, any doubt is there? Porter governor, how do you introduce Porter governor? It is a gravity controlled, centrifugal type, energy controlled type governor. This is the introduction. Now construction, what it consists of? It consists of 4 binary links or 4 arms, 2 upper arms and 2 lower arms. And also it consists of 1 sleeve and governor shaft and 2 governor balls. Then how the parts are arranged here? 2 upper arms are connected to the governor shaft axis, are pivoted at point O, and other end of the 2 upper arms connected to a governor balls. And lower arms, 2 lower arms, one end of the lower arms is connected to governor balls, another end of the lower arms connected to the sleeve. Again, sleeve is attached to where? Governor shaft axis. Okay, governor shaft axis, it is attached here. Okay, it is placed over that. Then this is our construction and label the parts. And what are the notations we use? Let m is the mass of the governor ball, small m is the mass of the governor ball, r is the radius of rotation of the governor ball, and capital M is the mass of the sleeve, right? Then due to rotation, due to at equilibrium speed, then once the governor shaft rotates, a centrifugal force is generated from the governor balls. What its magnitude is? Mr omega square. And weight of the governor ball is mg, that acts always, weight acts vertically downward. And mass is attached to her sleeve, that mass is capital M. The weight of the sleeve is acts also vertically downward. This is the construction. Then how it works. Then we go for, consider only the up portion of the governor, Porter governor on the left side we consider here. Now you can see that. Then our aim is to determine what will be the height of the governor. What is height of the governor means? It's a vertical distance between the intersection of the upper arm and the governor shaft axis and the radius of rotation of the governor ball. This is a vertical distance. That is called as the height of the governor. Height of the governor. Yes, regarding this, any doubt? Next, these are the notations what we use. H, height of the governor, it's a vertical distance from the plane. The horizontal, uh, the plane of the rotation of the balls to the point of intersection of upper arms along the axis of the spindle. The height of the governor decreases with increasing speed and increases with decreasing speed. How here the height of the governor, see, as the speed increases, the governor ball the moves radially outward. the now A become somewhere will come here A dash or A1. Now see the height of the, as the speed increases, the height of the governor is decreases. Now H becomes H1. As the speed decreases, the height of the governor is increases. That's the reverse it is. That is an, that is a statement. The height of the governor decreases with increase in speed, and when the height of the governor increases with a decrease in speed. Small m stands for mass of each ball in kg. Capital M stands for mass of sleeve in kg. Omega is nothing but angular velocity of the balls, arms and sleeve. All these parts are rotating about the governor shaft axis in radian per second. What its magnitude? Omega is equal to 2 pi n by 60. Where what is T? T1 stands for tension in the upper arm in Newton. T2 stands for tension in lower arms. Now R, small r stands for radial distance of ball, the center from the spindle axis. Yeah, now here you go for derive it, height of the governor, speed and height of the governor. How do you derive it? First you go for some assumption. What is assumption here? Assuming whatever the links are there, the mass of the links are we neglected here. And at the same time, we'll go for neglect the friction of the sleeve. That is friction will represent a small f of the sleeve. Now what is the friction here? What is the friction of the sleeve is nothing but, see that as the governor, okay, as the speed increases, the upper arms moves radially outward, the governor ball moves radially outward, the sleeve moves upward. Once the sleeve moves upward, there is a contact between the sleeve and the governor shaft axis, that the force which resists the motion of the sleeve, that is resists the a force which is occurred opposite to the motion of the sleeve, that force is called as a frictional force. This frictional force exists between the sleeve and the governor shaft. So if the sleeve moves upward, means frictional force is in what direction here? Opposite to that one is downward F. If suppose if the sleeve moves downward, if the sleeve moves, okay, I'll take in, okay, if the sleeve moves downward, what will the frictional force is? Frictional force is opposite to the movement. Frictional force is in upward. Remember this point is also very important one. Frictional force means a force which is offered against the motion of a body. When two bodies are in contact each other, if one body move over the another body, means a frictional force. At the contact surfaces, there is a frictional force existed which resists the motion of the body. That frictional force is also called as, in general, it is friction. Right? Yeah. Now, suppose if the mass of if the governor mass is at an equilibrium condition, static equilibrium condition, how it is equilibrium condition means what are the forces acting on the governor ball? See what are the forces acting on the governor ball? First force is a tension T1 is, okay, consider, yeah, what are the forces acting on the governor ball? One is a tension T1 is occurred on the governor ball. Second one is from the lower arms also a tension T2 is occurred, and third one is a centrifugal force which is generated by the radially outward force. The radially outward force is acting on the governor ball when balls are rotating, that is called centrifugal force. Another one is the weight of the governor balls. Right? These are the forces which are acting on the governor balls. Okay, now still 9 minutes is there. Once it is the session is completed, again you should rejoin the session. Yeah, these are the forces which are acting. One is tension in the upper arm, another one is tension in the lower arm, centrifugal force, and weight of the governor ball. These are the forces which are acting on the governor balls. Right? See that the mass m at A is in static equilibrium under the action of, one is tension in upper arm T1, second one tension in lower arm T2, third one is centrifugal force mr omega square, its magnitude, it acts radially outward. and fourth one is weight of the governor ball, that is W m into G in Newton. Now our aim is to calculate what will be the equilibrium speed or what will be the height of the porter governor. If speed is given, then you go for calculate height, or if height is given, then you go for calculate speed of the governor. Okay, then our aim is to determine speed and height of the governor. There are several methods are there to determine the speed and height of the governor. Here two methods we follow here. First one is we'll go for use a method of resolution of forces. What are the forces acting here? T1, T2, centrifugal force and weight. Then we'll go for resolve these forces on the governor ball. Second one is instantaneous center method. I think already studied about instantaneous center method in your fourth semester kinematics of machines. Okay, this is nothing but instantaneous center method is a graphical method. What is the first one? Method of resolution of forces means this is the analytical method. Okay, first one, if you go for method of resolution of forces, as you know that this is a governor ball at point A, right? So what are the forces acting on the governor balls here? One is tension T1 here, acting here, and centrifugal force, mr omega square, and the gravitational force of the governor ball is mg. These are the three forces acting at point A, right? Now tension T1 is there. Now we know that this angle, the angle between the angle of the upper arm, the inclination of the upper arm with respect to governor shaft axis, what is this angle? It is alpha. This angle is alpha. What about this also? Alpha, right? Now what type of angle it is? Yes, unmute yourself. Those who know, unmute yourself and tell me that angle. What type of angle it is? Why these two angles are equal? Yes? Anyone can give me the response? What is alpha? Alpha is the angular distance between the upper arm with respect to a governor shaft axis. Now this is alpha, right? At the same time, if you draw a vertical line from here, now this is also a alpha. Now what type of angle it is? Yes? Is anyone know this one? This is what shape it is? This is Z shape. Once it is Z shape, these two angles are equal. Then it is called as what type of angle? Alternate angle. The alternate angles are equal. At the same time, see that the angular position of the lower arms with respect to a spindle axis. Again, this is also in the form what angle it is? Z shape. Now this is also alternate angle. This angle is beta. Okay. Now we'll go for take tension T1. This angle is alpha. Now resolve at point A, resolve the force, resolve this tension in vertically and horizontally. Now if you go for resolve this in horizontally and vertically and horizontally, now tension T1 is in this direction. Now this consider hypotenuse. This is angle alpha. This is opposite side. For opposite side, which trigonometry relations will come here? Sin theta will come. Sin theta is nothing but opposite by hypotenuse. Then I want opposite. Opposite is equal to hypotenuse into sin alpha. Similarly, this one is adjacent side, cos alpha will come. Again, what is this adjacent side? Cos alpha is equal to adjacent by hypotenuse. Then adjacent side is equal to hypotenuse into adjacent side is hypotenuse into cos alpha. Arrow mark, how do you get arrow mark? Now the T1 is acting here vertically upward. Now from point A move, this one is vertically upward and move to go to right side. This is right side. Now resolving that force vertically, that is upward forces, and then are equal to downward forces. Then you go for resolve it. Similarly at point B also, at point B, the weight of the sleeve is acting here. That is mg is the weight of the sleeve divided by 2. Why divided by 2 is there? We'll consider only a half portion of the governor, right? Half portion from the this is a governor shaft axis. We'll consider only the one governor bus on one side. Another side also there. The total mass is divided by 2. That's why it called as total mass of the sleeve is divided by 2. On each side, mg by 2 acts on the each side. Total is mg by 2 plus mg by 2. Total mg.
Sir, voice is breaking.
Yeah, total voice is
Hello, sir.
Hello? Yes, my voice is audible. Yes, please check. My voice is audible or not? Yeah, total weight. Yes, someone has to give me response. Now my voice is audible.
Yes, sir.
Yes, sir.
Okay. Now PPT is also visible.
Yes, sir.
Okay. Yeah, we were this, right? Yeah, we were in this slide, methods of resolution of forces. Now this slide is visible. Let's give me response.
Yes, sir.
Yeah, my voice is audible.
Yes, sir.
Yeah, okay, thank you, ma'am. Now, similarly, go for resolve the force. First, you resolve the force acting in the governor ball. At the same time, go for resolve the force acting at the sleeve here. Total weight of the sleeve is mg, right? Now we split into two portions. We consider only the left side portion. Another side portion also there. That's why we go for divide by 2. Total weight of the sleeve is mg. Here on each side it is, what is the total weight of the sleeve is acting on each portion, or in each side it is mg by 2, mg by 2. If you go for mg by 2 plus mg by 2, now take LCM, finally get cancelled, then finally get total weight of the sleeve, it is only mg only, capital M into G. Again at the point B, see the in the lever lower arm, what the tension is acting here? T2. Again this angle here, the angle subtended by the lower arm with respect to a governor shaft axis, that angle it is beta. Now side which is opposite to the angle it is, this is the opposite side. The side which is adjacent to the angle it is for adjacent side. Again resolve that forces. Resolve the tension T2 into two component. One is horizontal, another one is vertical. Again you apply that, that is this opposite side. For opposite side, hypotenuse into sine beta will come. For adjacent side, hypotenuse into cos beta will come. Now how do you determine the speed and height of the governor? See that statement, resolving the forces vertically, that is upward forces are equal to downward forces. Now what are the upward forces are there? T1 cos alpha, then mg. The T1 cos alpha, take upward forces are positive, downward forces are negative. At point A, similarly at point B also, T2 into cos beta and mg by 2. Then resolve that forces into vertically, and then you go for equate it, then you will get the speed and height of the governor. Again for